Hello and welcome to the first lecture video for MATH0011 Methods 2. If you haven't watched the introductory video for MATH0011, I strongly recommend you watch that before the rest of this video. So go and do that now. You can find it at the top of the Moodle page for Methods 2. In this first 4 weeks of Methods 2, you're going to learn how to program a computer using the language Python. A computer program is just a sequence of instructions in a language that the computer can understand, often with the aim of computing something. In this video, we're going to learn how to do the simplest kind of computations, namely basic arithmetic in Python. In a Jupyter notebook like this one, the way we interact with Python is by typing in what's called a code cell. A code cell is one of these things with the word in and then some square brackets next to it. We can click in there to type. And when we type something like 2 plus 4 minus 9, in order to get Python to evaluate that, to tell us the answer, we then have to press Shift and Enter or Control and Enter. As you can see, when I do that, it prints the answer beneath the cell. Multiplication in Python is done with an asterisk like this, and division is done with a forward slash like this. Exponentiation in Python is done with 2 asterisks. If you want to know 2 to the power 4, you have to type 2 and then 2 asterisks and then 4. When I evaluate that with Shift Enter, you can see I do get the answer 16 as expected. On the other hand, 2 and then this symbol, a circumflex or a carré, does not compute 2 to the power 4 in Python. Before I evaluate that, another useful thing to know in Python is that if you use the hash symbol or the pound sign, Python will ignore everything following the pound sign. That's useful because you can use it to write comments to yourself to remind you what a particular piece of code does, or to tell somebody else reading your code what it does. I'm going to type a comment here to remind us that this is not 2 to the power 4. When I press Control Enter or Shift Enter to evaluate it, you can see I definitely don't get 2 to the power 4. Exponentiation in Python doesn't have to be to an integer power. That means we can use it to compute square roots and cube roots and so on, because if you have a number a, then a to the power 1/2 is the same as the square root of a. So here we're going to compute the square root of 2 by working out 2 to the power 0.5. When I run this cell with Control Enter, you can see I really do get the square root of 2. Going down a bit further, I'm going to work out the cube root of 2. But to do that, I need to use some brackets. So just like in ordinary mathematics, we use brackets in Python to tell it in which order we want it to do a computation. Here I want it to work out 1/3 and then raise 2 to the power of that. So I need to use brackets to tell it to do the division first and then the exponentiation. On running this, you can see I really do get the cube root of 2. Python will also do division with remainder. Here's a quick reminder of what division with remainder is. If you have 2 integers a and b, and if b is not 0, then there are integers q and r, where r is greater than or equal to 0 and less than the absolute value of b, such that a is equal to q times b plus r. So we call q the quotient and r the remainder when we divide a by b. In Python, you calculate remainders with a percent sign and a quotient with 2 division signs. As an example, let's say we want to divide 7 by 3. 7 is 2 times 3 plus 1, so the quotient here is 2 and the remainder is 1. When I run this cell to find the quotient, you can see I really do get 2, and when I run this cell to get the remainder, you can see I get 1 as expected. Scrolling down a bit further, let's do another quick example. If I divide 16 by 5, well, the answer is 3 remainder 1, because 16 is 3 times 5 plus 1. In this cell, I ask for the quotient when dividing 16 by 5, that's 3. And in the next cell, I ask for the remainder on dividing 16 by 5, and you can see I get 1. You've all seen these stupid memes on the internet, and the reason they're so stupid is that the sum which is written down in these things is confusing and ambiguous. The right solution to them is to use brackets to make it clear what you mean. Now, Python will evaluate any arithmetic expression even if you miss the brackets out. It has lots of complex rules to determine how to interpret arithmetic calculations. But you shouldn't learn any of those rules. Instead, you should simply use brackets to make it very clear what you want Python to work out. Let's look at a simple example of that. If I do 1 divided by 2 times 3, well, this is a little bit ambiguous because it's not quite clear whether I want to multiply 2 by 3 and then divide 1 by that, or whether I want to do 1 divided by 2 and then multiply the answer to that by 3. In fact, as you can see, when I run this, what Python has done is first done the division and then done the multiplication. So this is 1 divided by 2 all multiplied by 3. If I instead wanted to do 1 divided by 6, so 1 divided by brackets 2 times 3, I need to use brackets to tell it to do the multiplication before the division. So just like in ordinary mathematics, to make your meaning clear if you're using a complicated expression, just use brackets. What we're going to do for the end of this video is we're going to use what we've learned so far to find the roots of a quadratic equation. As you all know, if you have a quadratic ax squared plus bx plus c, you can find its roots using the formula which I've written at the bottom there. So let's solve 2x squared plus 5x plus 2 is equal to 0 using that formula. This is going to test out all of the different things that we've learned so far. So what do I have to do? I need to do minus b, so that's minus 5. Then I have to do plus or minus. Well, let's do plus first of all. Plus, I want the square root of something. So in order to get the square root of something, I need to raise it to the power of half, and I'm going to need to put my calculation of b squared minus 4ac in brackets. So here's some brackets. The b here is 5, and to work out 5 squared, I have to do 5 to the power 2, and then minus 4 times a, which is 2, times c, which is 2. Okay, we're raising all this to the power 1/2. So now we have the top part of the fraction. We now need to divide the whole lot by 2a. So you can see I'm going to need some brackets in order to make sure I divide the whole lot by 2a. So let's put the whole thing in brackets, and then we need to divide by, well, if I just do 2 times a like this, as you saw in those last two boxes, that's not going to work. We need to put brackets in it around this to tell it to do the multiplication before it does the division. So here, hopefully, is going to be a computation of one of the roots of that quadratic. We get the answer minus 0.5. So, well, was this correct or not? Let's try and work out whether this was correct. So a good way to check this would be to substitute back into the quadratic equation and see whether we get the answer 0. So I should do 2 times minus 0.5 squared plus 5 times minus 0.5 plus 2. If I calculated correctly, and if I've typed this incorrectly, I should get the answer 0. I do, so it looks like that worked.